Hey everybody, this is Larry. This is day 25 of the Leetcode March Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. So I don't actually wear glasses, but I'm trying this new thing where about blue light, yellow light, something like that. So I don't know. Looks a little funky on the thing though, but we'll see how that goes. Anyway, I usually start these lives, sometimes have a little minor daily update. But yeah, so today's poem is Pacific Atlantic. Waterfall. Given an n by n matrix, represent the height of each cell, touch the left edge and the Atlantic right cell. Okay. Water can flow in 4 directions. Find the grid coordinates where water can flow to both Pacific and Atlantic. Okay. Let's see. Of height equal or lower. Okay. Yeah, so I mean, I think there are two ways, maybe there are 2 ways to do it, but the way that makes sense most to me is just start, just do a breadth first search or depth first search. It doesn't really matter because it's a connectivity problem where, you start from the Pacific side, you try to see what cells you can reach by going up or equal, like basically the reverse of the problem. So one thing that I always urge is that, and this took me a long time to get used to when I was doing it, is that when a problem asks you for one thing, well, especially if it's an easier problem, well, just try to see if you could simulate it, right? And if you can, then, you're done. And, well, you have to do the math and calculate whether the math works out that it's fast enough, etc. If that doesn't feel like it could work, or at least that it may be too slow, you could, another common thing that I would do is just see if you can think about it backwards, where, because here there's an invariant of things can only flow from the top to the bottom, right? Or equal in this case. But in that case, you can think about this as almost kind of like a DAG. I know that in the equal case it's not quite right, but you can think about it as a DAG where there's or maybe just a regular graph. Then you have an edge between nodes that's going from a higher place to a lower place or equal to, so that you have these cycles. But yeah, and then now if you want to go backwards, now you have a lower thing and then go upwards, right? Basically just reversing all the edges on all the graph. So that's basically the idea. Why am I doing this? I think you can also do it. I think you can also do it the other way, where you can just for each cell do a depth first search to see if you reach Pacific and then do a second one maybe to see Atlantic, with caching and memorization. And when you cache, then that means that each cell can only be visited at most once. I think the reason why I don't like that one is that the reason why I don't like that one when I first thought about it, like 20 seconds ago or whatever, is that you get into the confusing states where you have 2, for example. Do you go to this 2? Do you go back to this 2? I guess not. But then there are just more states that you have to keep track of, and then they're just and there are definitely things you can keep track of to, I think, make this easier. But I think there's just uncertainty, right? Because in this case, okay, this makes sense that this goes to this 2, but what if this 2 goes to this 2 goes to this 2? Like if you do a recursive the other way, where you go from this 2 to here, then, it's not super clear that, these are transitive and you go here, right? But if you reverse the graph, then this is straightforward because you can, the invariant is slightly tighter in that if you start from the Pacific, then you could just do a breadth first search your way up, and then that this, you basically expand in instead of trying to figure out a way to do it backwards. And in terms of complexity, breadth first search is going to be linear in terms of the size of the input. And because it's linear, I know that's going to be fast enough, and that's basically enough for me to code. And of course, I know that I talked for a couple of minutes because I want to explain the explanation a little bit. But in general, if I was doing a contest, I probably would have started coding about 3 minutes ago or something like that. Yeah. Okay, cool. So let's get started. Yeah. And then for implementation, I think just thinking about what to do. Wait, Canfo, right? Okay, yeah. Just thinking about what to do. of implementing it in a easier way. I guess there's two ways to do it. One is just creating an extra padding for the, for up here, to the left, to the right, to the bottom, and then just like, choose those as starting points. I think you can actually also just start by these border points, because by default they're going to be connected to Pacific. So I think we just can start from these. That's okay, and then you do a second breadth first search on the Atlantic, and that should be good. And then you just do an overlap of those two reachable states. So let's do it. So let's just say Pacific is equal to, okay, let's actually set something up small. Rows is equal to the length of matrix. Columns is equal to the length of matrix of 0. And then Pacific is just, Atlantic, same thing. We'll use them separately later. Oops. Or maybe not. Maybe I could just Yeah, okay. Yeah, maybe this is fine. I was gonna think about maybe I can do not repeat yourself and abstract this a little bit. I might still. But okay, let's actually do that. Let's say by first search, let's just say starting points, and then here we can see reach is equal to this thing. And then Q is equal to collections.deck of starting. And because this is a breadth first search, we are okay with respect to the ordering doesn't matter, I guess is what I mean. Because I think that's just what I'm double checking. And then now we write the breadth first search. Sometimes I write this in a different order, like I write the setup before the breadth first search, but it doesn't really matter because I think at this point I have most of the code in my head. And also probably during a contest, I would probably just do it the naive way and not try to clean up the code as I'm coding, because I'm just trying to get it correct. It might involve some copy and paste, and honestly, it has cost me some wrong answers in the past, but it is more, it's faster for me. And yeah, I don't know. Maybe I have to fix that though. Anyway, so yeah, while Q is 0, let's see. Yeah, XY is equal to Q dot, oops. I've been writing that for some reason. So yeah, so then here we also set up the directions, which in this case I believe is just up, down, left, right? Yep. Right, in directions. And then okay. And then yeah, and then now because we always start from the points, so we can do something like, we just make sure that this is inside the bound before we check. And then the only thing that we have to check is that it is equal or greater than. So we check this is less than or equal to the next one that we visit, because we want to go upwards, and also not reach of nx and y, because if we could already reach it, then we're already going to it's already in the queue is what I'm saying. So then here we append nx and y, and that's pretty much it. Oh, I guess we have to set this is equal to true. Also yeah, okay, and also we want to actually set for xy in starting, reach of xy is equal to true. Okay, and then now we just want to return all the cells which has these. So yeah, maybe I'll just return reach. That's fine. I was gonna maybe return the tuple, but I feel like that's not as clean. Probably not. But yeah, and then now we can do something like, okay, Pacific is the top one, right? Top and left. So it's equal to BFS of how do I write this in a clean way? let's just say a list of 0x or 0y for y in range sub columns. And let's add this from, you know, x of 0 for x in range of rows. And I am aware that maybe we could add a set to this or something. I mean, I know that 0, 0 would repeat twice, but it doesn't matter because this becomes a no op because this is already done for all the adjacent cell. So okay, I'm just gonna leave it here for now. But I know that this is slightly not perfect, but bear with me, I guess. But yeah, so same thing here now. So rows minus 1 y for y in range of cows plus x cows minus 1 for x in range of rows, right? And then now we can just find the overlap. The order of the return corners don't matter. I mean, we're going to do it that way anyway. So yeah, results is equal to an empty array. And then now we do for x in range of rows, for y in range of columns. And then result and x of y if Pacific of x and y and Atlantic of x and y. Yeah. But yeah, this is just basically a reachability problem. Definitely, if you have trouble with this, practice graph problems and especially connectivity ones, and I think that'll probably be the way to go. Oh, whoops! How did I miss the entire variable name? Okay, so is this right? Seems to match up. They don't give us another test case, so let's give it a submit because I'm lazy. Ooh, no. I was thinking about like, oh, don't give me an empty case thing, which is a little bit of a gotcha, but it's fine. They actually been Leetcode has actually been better about that lately, about not doing this, but they don't even define it. That's why. I mean, I guess technically they define it, but it's still such a unnecessary case, right? Because it only fails on here, so. Yeah, I mean, it's fine. But sad. Because this is not even a valid input, maybe. I don't know. Either way, I mean, that's not... We're here to solve problems. We're not here to add if statements. So I'm not going to feel that sad about it. But yeah. Because, yeah, definitely in certain... contests and competition, they do expect you to do this, but from Leetcode, I feel like they've actually been moving away from that lately, which I'm happy about because I don't think that, you know, like there are ways to get edge cases that aren't just like, oh, you didn't read the problem carefully enough, right? Like that's, or like it doesn't teach anything or show anything, I think, but and also this is what having unit testing is for. But yeah, okay, so what now? Complexity. Okay, so I mean, this is just standard breadth first search, as I said. So this is breadth first search on the array starting from, you know, the left and the, you know, from one of the side or two of the sides, and then we do it twice. So, and each breadth first search is going to be linear time, and you know, linear for breadth first search is v times y, which where v is equal to the number of cells, which is r times c, and y is equal to the number of vertexes times 4, roughly. So this is going to be O of, you know, r times c plus more r times c times 4, something like that, which is equal to O of r times c. So this is linear in the size of the input, where the input is not just this, it's the matrix, of course. And we do it twice, so it's going to be still linear, and then we do one more linear scan to get the answer, and I guess the setup is also, oh, I guess that's it. I mean, I guess this is also, this is sublinear, but that's fine. But yeah, everything is linear, so linear time, and we have linear space with respect to, you know, these two matrices. You could probably reuse them if you really want to, but it's fine. I mean, that doesn't matter. Yeah, linear time, linear space. And when I say linear time, linear space, it is actually r times c for time and space. It's linear in the size of the input because the input size is r times c. That's all I have for this problem. I think this is, this is, I would say if you're having trouble with the graph theory or BFS or stuff like that and connectivity, like I said, practice that. I think the tricky part about this one problem is it does have that, hey, use this one trick to solve this problem. And that is thinking about things backwards and instead of, answering the question as they tell you, which is, water flowing from top to bottom, which maybe is intuitive. Try to reverse the problem and try to see if you can figure out another invariant there. That's all I have for this problem. Let me know what you think. Hit the like button, hit the subscribe button, join me in Discord. Hope y'all have a great day, have a great week, have a great rest of the week. Take care of yourself, take care of others, to good health and to good mental health. I'll see you tomorrow. Bye bye.